All right. So first of all, if you want to follow along today, you can go to my website, baharman.github.io/python-in-grass, and I'll post that here in Zoom. Now, if you do want to follow along, you'll want to install GRASS GIS if you don't have it, and download the sample data set for today. The sample data set that we'll use is going to be a series of aerial surveys of Hilltop Arboretum. So I'm going to show you how to import, process, and make maps automatically from a series of aerial surveys. This is an example of a good use of Python. So a team of us have been flying monthly surveys over Hilltop Arboretum with a drone, capturing it with a multispectral camera. And a little Easter egg over here. Smiley face of ground control points. I believe we've maybe flown about 8 missions now, and we're going to process the data the same every time. So it makes sense to start to automate this. Outside of GIS, we're doing a lot of processing, and that can be automated with Python as well. This is Metashape, the drone photogrammetry software we're using to turn the hundreds of photos taken on each mission into a point cloud. This is a representation of the latest point cloud from August, and I export this as a geotiff for use in GIS. So what we're going to do is look at importing all of the geotiffs at once into GIS, do some processing on them, and then export some maps. So I'm going to go ahead and start GRASS. And I'm going to create a new location. So I set my GRASS data directory. I'm going to create a new location, and I'll call this something like Hilltop. I'm going to create this from an EPSG code, the same one I used in Metashape. So I'll set this to, I think, 6478, maybe. Right. So this is for the North American datum of 1983 for Louisiana state plane meters south. And I'm going to open up GRASS in that new location. So with geospatial programming, we can do a number of things. We can automate the import and export of data, which can save a lot of time. We can also automate geospatial computation. So we can do, instead of having to manually repeat tasks, for example, and run the same thing on a lot of data, we can automate it. And these tasks are relatively easy. You can also automate the production of maps. So if you set up a nice map style, you can just generate maps from the same commands for all of the maps for all of the data you have. The most exciting thing you can do is start to, develop your own geospatial software. In GRASS, it's very easy to create new add-on modules using Python. That I'm not going to cover today. There's two basic ways to work with Python in GRASS. One is inside of GRASS. There's a Python shell, and you can see that in the layer manager in the Python tab at the bottom. With this shell, you can run Python commands line by line here. So, for example, a classic first thing to try in Python is a print statement saying, hello world. So I'll type that, put in the print method, and this is going to be text, so I'll put a quotation mark, hello world, and I end the text with a quotation mark. And all functions in Python have parentheses around them, so I'll close my parentheses and run that. And it just prints hello world. Very simple. Classic test to see your Python's working. If you want to run a whole script and not just a line, there's a simple editor in the bottom of the Python shell window. You can open that up, and this will bring up the simple Python editor here. This is nice. It allows you to load scripts, and save them, run them here inside of GRASS, and set a parameter to overwrite your data. There's also templates and examples that you can load. Another way to do this is to write your Python script in a text editor or an integrated development environment. So this is the one I like to use with GRASS. It's Atom. It's a free open source text editor sponsored by GitHub. And you can extend it with a lot of features by adding on add-on packages. And you have a lot of control over syntax highlighting. And you can add packages to check the style and to check that your Python code is okay. There's also full integrated development environments, IDEs, that you can actually run the scripts in. But here we really want to run GRASS inside of Python. Python inside of GRASS, so that we can use the GRASS libraries. It's a lot harder to set GRASS up to run GRASS in Python outside of GRASS. It is possible, but you have to set up a bunch of environment variables first. So the easiest way to run Python in GRASS is to start GRASS and run the script inside of it. So if I write a script outside of GRASS in a text editor and I want to launch it, instead of opening up the editor here, I can just go to File, Launch Script, and browse to find my script. And if I hit that, it's going to run. I could also load it here in the Python editor. I could copy and paste it into here, or I could go open, I could browse and find it and select it. So there's two different workflows. And we're going to look at this one for first of all, what a basic command looks like in a basic Python command looks like for GRASS, and then we're going to import the maps. So first of all, if we want to import a map into GRASS, we'll use the module rngdal. So we're going to import raster data. So R for raster, N for importing data, bringing data in, and GDAL for the data, geospatial data abstraction library. So I can simply type that in the console here at the bottom. If I know what my command is, r.in.gdal, and enter to bring up the interface. I can also find this under File, Import Raster Data, Import Common Formats, rngdal, or go to Modules, Import Data, Import Raster Data. And this is probably a nice way to do it right here. So rngdal. This is probably easiest to do the first time using the interface here, because you need to browse and find the data. So in the first tab required, I need to find the raster map I want to import. And if you downloaded the sample data set for today, put it in your GRASS data directory, extract it, and you should have Hilltop drone data. And your TIFFs, your GeoTIFFs will be here, 6 of them. I'm going to pick, say, the first one for March, and I'll import that. I'm going to give it the same name as the input minus the TIFF, because it's going to be a GRASS raster. And that's pretty much all I need to do here. I'll run the command. And you'll see at the bottom of the command here, the bottom of the interface, that it has the text for the command. I can copy that to the clipboard and, for example, now paste it into the console if I want, with the full file path, if I wanted to, say, save it or run it again. And now I should have this raster map here in GRASS. So that's importing a raster data using a regular command in GRASS. If we want to put this into Python, it's going to look a little different. The first thing we would need to do is this is a Python shebang, and this is just telling Python that this is a script, a standalone script that you're going to run using Python 3. So this should be at the top of most scripts. And then we need to import the GRASS scripting library. By convention, we'll do this as import GRASS script as gscript, so we don't have to write GRASS script out every time. And then to run a command that looks like this regularly in the console, we use the run command method from gscript, from the GRASS scripting library. So gscript dot run command, and this is a function, so we put parentheses around it. And inside of it, we're just going to put the what would have been in that GDAL command, rngdal. So r inside of parentheses, inside of quotation marks, r.in.gdal, a comma for the second part of the command. And we can just write this out on one line, but to keep it neat, we can break it onto separate lines. as long as we indent this with a tab. So Python will know that this is part of the same command if there's a tab here. So I'll do input, and then I need to put the full file path here. So I'll copy this. Oops. So input equals, in quotation marks, the full file path to the data, the GRASS data, Hilltop drone data, and then the name of the TIFF. A comma at the end of this, another line, output equals, then again in quotation marks because this is text, the name of the output map, so surface. And I can add a final thing to the command just to make sure it runs it again. If I want to make sure it overwrites the past data, I'll put overwrite and then a Boolean value for true. And now this should run. If I hit the run command here, it's going to run and it re-imports this data. So writing a GRASS command in Python takes a little bit more work, but once you have this basic format, it's pretty much, it's pretty easy to build it off of a regular GRASS command.
Hey, Brandon, the yeah. Overwrite command doesn't need to be in quotation marks?
No, because this isn't text, it's a Boolean. So,
right, okay. Okay.
Now, if we want to import all of these maps from the drone Hilltop drone data folder in one go, that's something that's Python's going to be much more useful for. We're going to use a bit more in this script. We're going to import another library, the OS library. This library is good for handling file paths and other things like that that are operating system specific. So one issue you get to is Windows, Mac, and Linux all write their file paths differently. So this library handles that.
I'm running into that issue on my end with the Mac. Getting some syntax error, but we don't have to.
I'm going to show you a really
easy
fix for that, hopefully, with this next step.
Okay.
It's a little more complicated, so I tried to leave it till next. But there's some OS path commands. For example, OS norm path, I think, could fix your file path, perhaps. What I'm going to put in here is the GRASS environment settings. So where you see, what do you call the number symbol here? Where you see this number symbol is a comment in Python. There's two ways to make comments. You can either put a single line with a number symbol, or you can put a fence of quotation marks. So 3 quotation marks in a row, 3 double quotation marks. Everything inside the fences of quotation marks is a comment. So comments are just notes. They won't run in the command. Sometimes at the top of the script, they're telling Python where the Python path is, what the text encoding is, and maybe you put metadata at the top, like who the author is, what the license is. Well, so this is just a comment telling us these are the settings. This is for our sake to read this. Then here I have some of the settings. we're creating a variable for the grass environment. We're setting overwrite to true. So we have an overwrite variable. And we're creating a variable called GIS dbase, which is going to be set to our grass data directory. And we're setting the location to the current location and map set variable to the current map set, which is permanent. So if I want to find this file path now, I can do this with, I can set the path. I make a new variable called data for my data directory, and I'm going to use the command ospath.join method. And here I'm going to separate by commas the different parts of this. So I start with GIS dbase. So that's going to find the file path to my grass data directory. Then I'm going to put in, as the second part of it, the Hilltop drone data folder. And now let's see how this works. I'm going to put a print statement, print data. So it's going to print the path to the data directory. And you can see that it shows up in my console here, d:\grass data / Hilltop drone data. So that looks right. And I can use that as the file path for importing my data. So now I can just use a variable. Next, I'll set the region. And I don't necessarily need to do this in this case, but I will. I always do it. Gscript, run command, and then I'm going to put the command in quotation marks. So g.region in quotation marks, comma for the next part, and I'm just going to set the resolution to 0.1. And that's not in quotation marks because it's a number, parentheses to end the command. I'll go to the next one. So another comment to say I'm going to start importing the data. And what I'm going to do here is make a for loop. So for file in, and I'm going to use another function from the OS library, OS lister. And this lists all of the files in a given directory. We could actually try that first. Well, okay, OS lister, and I put in the variable data from my data directory, colon, and this everything inside the for loop is indented. So let's test this. I'll try print file. So files inside of the quotation marks. It's a variable, and it's going to be a variable for each iteration of the loop, showing the raster, full file path. There you can see just the name of the raster. So it loops through all of the files in the directory and prints the names off one by one. So now instead of printing the name, what we're going to do is run rngdal.
Before you do that, Brendan, can you go back to setting the data variable?
Yeah.
Sorry.
Right here?
Yeah. So you're creating a variable called data.
Yeah.
Right, and then that you're saying that variable is equal to the path of, yeah, okay.
The path of my grass data directory plus the name of this folder. And this is just the zip file you downloaded. You place it in your grass data directory and extract it, and make sure you keep the folder.
Right.
So if you're doing Python in Grass and you want to avoid a lot of problems with different paths on operating systems, absolute paths when you're sharing it, I think the easy solution is put it inside your Grass database directory. Grass is going to find that in its environment variables. And if you do your work inside of the GRASS data directory, your life will be a lot easier. You can put things straight in a map set, well, probably straight in a location, for example. So in our final step, we're going to produce a bunch of, save a bunch of maps out, and we'll be saving that into the location itself.
Guess let me try something.
So to import the data, I'm going to use the command gscript dot run command. I'll go ahead and make both of my quotation marks, and then single quotes here. r.in.gdal. Outside of the quotes, and inside of the parentheses, I'll put a comma, new line, indent twice, so that I'm inside of the for loop and still part of this command. I'm going to write, let's see, input for the input map equals, and I'll fill that in a second. I'll put a comma for the end of the line. Next line, output equals, comma, new line, and then I'll put overwrite. This time equals overwrite. I've already set a variable called overwrite to true, so I don't need to write overwrite equals true on all of these, because then if I wanted to switch it to false, I'd have to change all of them. So that's why we typically use a variable up here at the top, because I can change this one to false, and they'll all change. You could easily do that with a find and replace command, but this is a bit better way. So for our input, we're going to use OS path again. So if you remember when we printed the map name of the map, the file in list directory, it's just the name of the map, the name of the raster.tiff with the extension. So we need the full file path here. So I'm going to do os.path.join parentheses, and inside the parentheses, I'm going to put my data folder, comma, and then my file. So data, comma, file. And if you wanted to check that, you could put a print statement before this and just try os path print os path.join data, comma, file. For my output, I'm just going to put oh, I skipped a step. I suppose I skipped a couple steps. I want to find just the name of the file without the extension. There's a bunch of ways I could do this. One way I could do this is just file, and let me check the right notation. From the end is I think it would be -4, and then a colon. So I'd say from the end, strip off the last 4 characters. But what we're going to do is, before this, create a variable called file name. So at the begin, right inside the for loop, we're going to make a new variable called file name. I'm going to set this to os path dot split text. And what I'm going to do is just split the name of the file from the extension. So what split text will do is I put the file in, and then I put an index in. And let's put a print statement here so we can see what it does. Print file name. I'm going to comment all of this out. I don't think this editor lets you comment everything out at once easily. And I'll run that. So now it's showing me that the file name is just going to be the file name without the extension. So that's what I want for putting this inside of GRASS. Take out these comments. And now for the output, I'm going to just put file name. So I can keep things nice and short by using variables. And that's enough to run this. In the example on the web page, I also put an if statement to check if they were actually geotiffs, but that's extra. We can skip it. And so let's go ahead and run this, and we'll import the all the maps. There's a bug. It's going to show up right here. Oh, I just made a typo in output right there. So I'll run that again, and it's going to successfully importing all 6 of my maps.
Brendan, could you just say a couple sentences about looking through that stack trace and how you're able to look at that error message and get an idea of where the error was?
All right, so here's my error message, and it's rather long.
Yeah.
At the top, it's telling me that I was running RNGDAL. What I really want to look for is right here where I see error, and this is telling me the problems.
Mm-hmm.
It's telling me output is not a valid parameter, and output, the parameter output is not set. So it's pretty clear I just misspelled something. Reading through this can take a little bit of practice. But the console can help you debug normal GRASS problems and Python problems as well. You can add extra debugging things to your Python scripts, which is often a good idea, but I'm going to keep it simple here. Hopefully simple enough. Now, if we want to not only import these data, but also process them, we can do that inside of the for loop, or after the for loop's over, we can list all the rasters that are now in the map set. So if I just wanted to import one raster at a time and do all the processes for it, I could just add the next gscript run command right here. So the things I probably want to do are set the color table, compute a hill shade, and then make a nice shaded relief map. If I want to import everything all at once, maybe take a look at it and then run another script to process it, that's fine too. In that case, what I would do is list the rasters in the map set. So I'll go outside of the for loop, and I'm going to put in a new command. I'll make a new variable called raster list to store the output of this. And I'm going to write gscript dot list grouped. This is actually a new command in that's specific to Python. In Grass, you just use g.list. Here, we're going to use the list grouped function instead. There's a few peculiarities to the Python scripting library like this. I need to specify that this is a raster type as opposed to vector or something else like space-time raster, space-time vector, or a database or something. Pattern is going to be the search pattern. So I'm going to list everything that in the map set that says this pattern. I'm going to put surface, because all of the maps are called surface, underscore, and then I'm going to put an asterisk. That's a wild card. So it means anything after surface fits the pattern. And then finally, outside of the parentheses, I put the parameter for the map set. And that's just saying list everything in this map set. So we'll be looking in the permanent map set, the only map set that there is for this project. And for our sake, we'll go ahead and print the raster list so we know what it looks like. So I'm putting the variable raster list inside a print statement. I run that. I'm just going to run the first part of it again. At this point, maybe I should delete that or comment it out. But here you see the list. So the list in Python syntax will be inside these square brackets. The name of the map is text, so it's got quotation marks around it, and you see the list of 6 maps. I can use this list to do a for loop. So I can do for raster in raster list, then a colon to say I'm starting the loop, and indent to say I'm inside of a for loop, and I'll put a print statement. So print raster, run that, and I'll go ahead and either comment out or delete this import data from our script for now. And it's going to list each one by one as it iterates through the list. So now if I want to run a computation on these, it'll be easy. Show you an example. I'm just going to copy and paste this in for time's sake now. I think you're getting a sense of what the commands look like, right? So I'm going to set the region, gscript run command g.region. I'm going to set it to the current raster in the list. Some of them have different sizes and extents. I'm going to set the color table to Viridis with a histogram equalization. I'm going to run shaded relief, exaggerated 3 times. And here's a note. On the name, I'm going to give it a new name for the relief map. I'm going to call it relief, and then take the last 11 characters of the name of the raster map, which is just the date, this part. So the output for this will be relief underscore 2020-03-19, for example. Exaggerate it 3 times vertically, and then make a composite shaded relief map combining the relief map and the digital surface model, the color table for it. I'll go ahead and run that. And it's going to take about a minute to do all of the computations. Whereas it would probably take me 15 minutes to run that one by one in the command line. The final step to this would be to list all the rasters in the final step to this would be to export the maps automatically. So I could create a nice sequence of maps like this with shaded relief and elevation color table for each step in the time series. And if you look at this, you can start to see, for one thing, the trees coming into the leaves coming out. You can see the meadow plants here at Hilltop start to grow and really start coming out by June, getting really dense into August. So to do this in Python, well, first of all, we can see that the processing just finished, 1 minute, 16 seconds. Now, if we want to automatically render this and save all these maps out as PNGs or JPEGs or something, we can do it quite easily. What I'll do is just use this list command again. And instead of doing surface, I'm going to do shaded _ asterisk as my pattern. So anything that has shaded at the start of it. And we can print that list. And you see I have a list of all those 6 shaded relief maps. We're going to do a for loop. So for raster in raster list. Could set the region again. We could even zoom in and set the region somewhere right here. So if I was to zoom in out in grass right now, for example, so, and set my map display here, set computational region from display, GRASS is going to use those settings. The Python script will use those settings too if I don't run a region command over it. So in this loop, I'm going to skip running the region, and what I need to do is start a graphics monitor. So there's a command for this called d.mon, and it's essentially what makes this window. And instead of creating a new window, what I'm going to do is I'm going to write to a file. I'm going to use the Cairo library to write this monitor straight to an image file. So that'll be gscript run command, and then the command d.mon for monitor, starting the Cairo driver. I can specify a width and a height. And I can make the size really large because this is a high resolution. This is at 10 centimeter resolution. Then the output path. And this is a little different than before. I'm using os path join, and I'm joining the GRASS data directory. Then the location that we're in, we made the Hilltop location, and then the name of the raster plus a PNG appended on the end.
Brendan, are the units for that width and height, is that in pixels?
That's in pixels.
Okay, thank you.
So this will come out to about 1 megabyte as a PNG. The raster, of course, has a lot higher resolution than that, so you could make the width and height really big if you want. Then the main thing we need to do is, now that we've started a monitor, we need to actually add a map to it. So you can add multiple and you can add map elements, but I'm just going to keep it really simple. I'm going to use the command d.rast, so display raster. That's the command that adds anything to your map display, any raster to your map display. Map equals, and then the variable raster for the raster in the list. That's going to add it to the graphics monitor, which is writing it right to this file. And then I just finish by stopping the monitor. If you were writing a nice script, you'd put some sort of error catching at the end here to make sure if there's a bug in the script that you actually, and the script has an error and stops, that you actually force the graphics monitor to stop. So it's not still running in the background. But that's extra stuff. Let's go ahead and run this. And you can see the progress bar, each one going. Finished in 7 seconds. And I'll go look in my GRASS data directory in this new Hilltop location. And you can see right here the 6 maps I output. Windows Photo Viewer wants to behave. I didn't have my map display perfectly square, so I have a little white strip on the edge, but could resize the window and set the region again to get that right. So there's my sequence of maps. And that's the conclusion to this very brief introduction to Python and GRASS. Any questions, comments?
This would have, having this knowledge would have been really helpful when I was doing all those models and simulations for my thesis. I know you mentioned at the time, suggested I look into this. It just felt so over my head.
But it's not that hard.
No, it's not. It's not. You just have to have some kind of basic familiarity with kind of principles of coding and I think the graphical modeler definitely makes it a little bit easier if you don't have that kind of baseline level of coding familiarity. But yeah, this is great.
I think in the long run, this actually becomes a lot easier and much more powerful than the graphic modelers. But
yeah,
there's
Oh, sorry, Brendan. I was going to say thanks for showing this, because I know I struggle with the graphical modeler sometimes. They can be a little buggy.
Yeah. And all of the graphic modelers for ArcGIS, QGIS, and GRASS are limited in terms of what you can do with flow control. So there's you really get the full power and potential with Python.
And also they're very limited in what you can do with the string manipulations. Like you know, you changed the name of the raster to add the relief. And so I think using this environment as opposed to the graphical modelers, it just opens you up to all of the default Python string handling. And as we saw, all of the path handling, there's plenty of other path related, you know, functions that are really helpful. So yeah, I agree. I think that focusing on learning some of those fundamentals is just really helpful. And it makes this kind of thing very achievable.
Yeah, the basics that you really need to learn for Python are flow control, things like loops, for loops, if then else statements, that sort of thing. String manipulation, definitely. How you work with text, and I suppose also dealing with file paths, pretty important too.
Yeah, Yeah, and like stripping, stripping the last 8 characters off of the name to change. I think there's a lot of good utilities to learn. One thing I wanted to mention is that I presented last year about using Python and QGIS, and in a not even that abstract way. There's a lot of similarities in terms of the structures of how these operations are set up. And so there's obviously it's the same programming language of Python, so you have a lot of the same like syntax and all of that. And then there's going to be differences in the commands, the specific QGIS commands or the R command or the GRASS commands. But there's a whole other level of Python of just understanding how scripts interact with software that's very applicable between the two. So I think it's important to recognize some of the similarities in terms of how code is implemented within software like this generally.
Right. Yeah.
And if you start to get into Python, some of the fun things that can happen next are if you want to make data graphics, plots, and charts, you can take your data out of GRASS or Q and use a library like R language or a library like matplotlib for Python. There's also the pandas library for data handling and some other great ones too.
Brendan, you walked us through some this is a pretty basic kind of workflow and a really common task. Like if you have a bunch of data that you need to import and process, kind of bulk processing. But I'm kind of curious, what are some of the more in addition to styling and you're plotting your data, like you just mentioned, what are some of the more powerful applications of approaching GIS from a Python first kind of standpoint?
One of the tasks for geospatial programs, obviously, just automation. So there's a lot of bulk tasks you have to do in GIS that are really boring and tedious and could give you carpal tunnel syndrome. So part of it's just about efficiency. Where it gets really interesting is when you start doing geospatial software development. So you can, for example, just write a script to do a new computation, or you can even implement a whole new add-on for GRASS, for example, or Q. And with that, you can, for example, use map algebra and the Python libraries like NumPy, SciPy to do some spatial computations and make something new.
So Tanvi, we probably could have scripted out that entire process that we went through to get the cost maps and the starting and ending points for LS corridors.
Yeah, you could have automated the whole LS corridors thing, and in fact, after you did so much and you looked at the source code, you probably could have written a better, maybe with some help, written a better script.
Well, we still learned.
We all
A slow way.
Yeah.
But Adam, you helped me out with this for CSS by writing that script. And I know I ran it in Q, but that saved me hours and hours of work. So definitely something to learn.
Yeah, again, it's just being familiar with like Brendan said, the flow control and being knowing how to iterate things, and then kind of the nuts and bolts of actually running some of those algorithms can be tricky, especially when you end up with some errors like Brendan saw today. It's just, I think what's really hard right off the bat is knowing how to fix things when they go wrong. because it takes a lot, like Brendan mentioned, it takes a lot of practice to read those error messages because there's so much in there that isn't going to help you, but then there's like a few lines in there that are going to be specifically what your error is. So
Right.
this is a lot of practice, I would say. Yeah.
A good way to start learning and a good way to write your code is to go through it slowly and put a lot of print statements in and test it as you go. Make sure you know what everything is actually producing. So I think some of the other recommendations are actually to rely on copying and pasting a lot, so you don't make typos.
Especially from your own notes, it's very helpful to keep notes and like I have.
So recycle your code.
Yeah.
There's a point where you want to practice code, but recycling is both efficient and reduces the risk of errors. For a specific workflow for GRASS, I think the really useful thing is run the command regularly in GRASS, get the command output, copy that command line text, and then you can turn that into the Python code really easily. So try your workflow first in the GUI or the command line, save the output, and then you can build a nice script.
How would you, like talking about reusing code, how would you go about saving something you wrote and using it as a kind of standalone function that you're just, or like, I guess building your own library, I guess is what I'm asking. Your own library of functions that you can just call on as opposed to rewriting that code over and over again.
Well, definitely save your Python files and keep them organized.
Well, I guess I mean more in like a, like to start out with, you imported the GRASS scripting library and then called upon gscript.run command. So like, how would you go about, a group of people wrote gscript.run command, right? So I guess I'm saying, how would you go about building your own library of kind of that you import and call upon functions and commands in that library, if that makes sense?
Well, what I would say is you dig deep into Python documentation, and especially like Python module management, and because it just gets into sort of a I think that's one of the most exciting and fun things about it, is if you start with something very small, like we had a little snippet, and then you're like, okay, I want to store that outside. How do I pull that in? It gets very complex very quickly though, especially when it comes to like loading scripts from your own modules based on paths and path environment variables. So I guess
you can save things. Oh, never mind. I'm not sharing my screen anymore.
What I would say quick then is you become comfortable running Python code outside of GRASS and just get more comfortable with it as a program writing language. So if you have, for example, a .py file in a directory, and in the inside of that file you just have a print statement, like the hello world print statement. If you in the command line run Python and then the name of that file from within the right working directory, it's going to be running your file as a Python program, and you'll see the output in your console. So then if you make a file next to that file and you can like import functions from one into the next, it can just kind of build from there. So there's no quick way to go from what we just saw to, from Brendan's code, import my function I had before, because it relies on a little bit more of a deeper infrastructure that you would need to build in terms of just directory structures and things. But Brendan, were you going to say something about loading up saved script files?
No, not really.
Well, I was just, the final thing I was thinking in response to Andrew is like, what you just wrote out, QGIS and GRASS and most other softwares like ArcGIS, you can write those kind of long snippets and then save those as files, which you're not going to run them separately as standalone files, but you're able to load them back in at a later date and just have all the code recycled. So that's really the way to go about this, is keep those files saved. You're not going to run them by themselves on your laptop, but you're going to import or load them into the software and then go from there.
Hey, I've got another question. When you showed us, Adam, how to use basically this in Q, weren't you able to use the graphical modeler and export Python script from the graphical modeler? Am I remembering that right?
Yeah.
Can you do that with GRASS too?
You can. I'll show you real fast.
Yeah.
Because that seems very useful for getting started on how to do this.
Absolutely is. Yeah, totally agree.
But
ArcGIS
it's rarely as
simple.
clean as it should be.
But it gives you a starting script that you can modify then, right? And kind of figure out what the different pieces do. Because you know what they did in the graphical modeler.
Mm-hmm.
In GRASS, we have a graphic modeler here under File, Graphic Modeler. And there's, once you've made one, there's a little Python icon here to export it.
Yeah.
Python script. You can get it right there.
That's a great point, and it's a really good place to start, I think. It's kind of, you start from two different directions. You can start from that direction where you set everything up and then you export it and then look at the exported script and kind of make little modifications here and there. Or you start with what we did, which is kind of building up from scratch. And I think keeping both of those perspectives in mind, because if you're able to build the for loops like Brendan did and change some of the variable names like Brendan did in the console and where we were running it this time, but then use maybe the graphical modeler output to mock up some of the specific sets of function runs, you may be able to just export and then copy some of that code into your own. So.
Well, this has been great. Thanks for the tutorial, Brendan. Really helpful.
One thing I'll mention before you run is, in addition to exporting it to a Python script here, there's also the Python editor here, which is going to go ahead and show you what it looks like.
Oh, nice. That's very cool.
So as you build it, you can just check the Python editor, and you can mix and match. You can start writing it here as well.
That's cool.
Does the Q graphical modeler do that too, Adam?
I'm not sure about this specific window that Brendan just opened, but I know you can export the model contents. I'm not sure about editing the Python of the model within it. Yeah, I haven't tried that. That's pretty cool.
Yeah, nifty. Thank you, Brendan.
Sure.
Very useful as always. Attending one of these things for an hour, I learned a couple of years worth of tricks. It's great.
Yeah, thanks, Brendan.
Okay.
Great, thanks everybody. Glad you showed up. We'll figure something out for next week. Again, if anyone wants to present anything, it could be super short. It could be, this is how I mapped the houses I've lived in on Google Maps, for example. Or I could even, let's see, someone crashed into our rental car a couple months ago, and it turns out now he's gonna try and say it was our fault. So I was spending a lot of time on Google Maps yesterday mapping out the intersection.
I've done that too, actually. I was rear-ended a couple of years ago. I did exactly the same thing.
Yeah, it can be helpful.
Said it as a lawyer.
Yeah, it felt like
Adam,
I have it all in my head. It was great.
Adam, I have one quick suggestion for a future topic. Just showing people how to access REST services, because that has like changed a lot for me. So
What service?
REST. What does it stand for? I don't even know.
I don't remember what it stands for. It's basically a protocol for data transfer, but specifically, I think you're thinking of like ArcGIS REST services, which is basically an endpoint that is created on top of ArcGIS server implementations, and which basically opens up access to all of the East Baton Rouge Parish government. Anvi, I wonder if there's someone who's enthusiastic and interested in that topic who would love to just give a little
I think
talk.
the motto of this group should be "Great idea, thanks for volunteering."
Huh?
Yeah, I can do that. Although you'll probably have to provide the technical details on it. So it'll literally take 5 minutes to show you guys what
Well,
it is.
Look
yeah,
forward to
let's
it.
talk about it because I think that would be really great, and it's super duper helpful. I completely agree.
Very
Completely.
helpful.
Yeah.
Cool.
Cool. We will talk, and maybe next week. Who knows? It's a good idea. Great. Well, everybody, thanks a bunch for showing up. And yeah, I'll probably send like an email out at the beginning of next week or something. And I will put this video on the website like normal. So.
Thank you.
All right. Yep. Talk to you all later.
Bye, all.